All right, so today we're going to introduce what is called the chain rule for derivatives. And it says this: if g is a differentiable function at x and f is a differentiable function at g of x, then the composite function f is equal to f of g, defined by big F of x is equal to f of g of x, is differentiable at x, and f prime of x is given by the product f big prime of x is equal to f prime of g of x times g prime of x. In Leibniz notation, it's written as dy dx is equal to dy du, du dx, where u is g of x. Basically what this rule says is if I have a composite function, so a function inside a function, that I take its derivative by taking the derivative of the outside function times the derivative of the inside function. Now, one thing you want to notice, though, is that when you take the derivative of the outside function, that you still have inside that derivative the original inside function. All right, so let's take a look. Example 1, we would like to find f prime of x if f of x is equal to x squared plus 3x plus 7 to the 10th power. Now note here, we do have our inside function here, this quadratic x squared plus 3x plus 7, and that function lives in this outside function, x to the 10th power. And so according to our rule, our chain rule, we will take the derivative of the outside function first. Our outside function in this case is that something to the 10th power. So if we do that, we use the power rule, and it's 10 times whatever that something is to the 9th power, right? Because remember, the power rule says the power comes out front and the degree drops by 1. Now note, when you do this, this time we do have something that's inside that's not just x. So we still have our x squared plus 3x plus 7. Now that there is the derivative of the outside function. But remember, the rule says we take the derivative of the outside function times the derivative of our inside function, which is this one right here in yellow. So the derivative of x squared plus 3x plus 7 is 2x plus 3. And so our answer is 10 times, let's go ahead and distribute the 10. So 10 times 2x and 10 times 3, so it's 20x plus 30 times x squared plus 3x plus 7 to the 9th. Now the reason I made the decision to distribute the 10 to the 2x plus 3 is because it didn't have a power that was essentially trapping what was inside, right? So this 9th power prevents us from distributing the 10 into it because it doesn't have a 9th power. Now, in reality, we could leave the answer as is on that first line. It would also be correct. All right, example 2. Find f prime of x if f of x is equal to x squared plus 2. All right, so once again, we have here our inside function. So that's our g of x. And then we have our outside function. That's this square root. Now remember, the simplest way to use power rule on radical functions is by first rewriting it as a power. So mathematically speaking, this is x squared plus 1 to the power of 1/2. That way, when I take the derivative, I'm going to take the power rule of the outside function. So that's going to become 1/2 x squared plus 1 to the power of negative 1/2. That's the derivative of our outside function, times the derivative of our inside function. Derivative of x squared plus 1 is 2x. And then if we simplify this, 1/2 times 2, those cancel each other. So this will cancel this. And then this x squared plus 1 to the negative 1/2. Remember, the negative means it's in the denominator, and the half means it's a radical. So this is x squared plus 1 square rooted in the denominator. And then in the numerator, we're left with x. And that's it. All right, example 3. Let's differentiate these two functions, and let's differentiate, pun intended, the difference between them. So this first function, you'll notice, is sine on the outside. So this is our outside function. Moment. So the sine is the outside function, and our x squared is our inside function. So remember the rule. If we're taking the derivative, let's use a better color. We have here y prime is equal to the derivative of the outside function. Derivative of sine is cosine. Remember, we keep the inside function, we take that derivative, times the derivative of the inside function. So derivative of x squared is 2x, so we would write this as 2x cosine of x squared. Now, the second function, mathematically speaking, sine squared x is actually sine of x squared. We tend to write it this way though. So what happens here, we've written it as a power, but this time our outside function is the square, right? So we see this as our outside function, and then this time sine of x is our inside function. So when we take the derivative, we take our outside function's derivative first, so that's just 2, whatever the inside is, so sine x, times the derivative of the inside function, which is cosine of x. So we get 2 sine x cosine x. Now do note, it's super important to pay attention to the difference between these. So really clearly identify which function is on the outside versus which one's on the inside. All right, example 4, differentiate. Y equals x cubed minus 1 to the power of 100. All right, so let's find the derivative. So once again, what's our outside function? It's that 100th power. What's our inside function? It's this cubic. So x cubed minus 1. So the chain rule says take the derivative of the outside function. So 100 times whatever's in the inside to the 99th power. That x cubed minus 1 is on the inside, times the derivative of the inside function. The derivative of x cubed minus 1 is just 3x squared. So mathematically, when we simplify this, we get 300 x squared times x cubed minus 1 to the power of 99. All right, so here's our last example. F of x is equal to 1 over the cube root of x squared plus x plus 1. Now, once again, remember our first step in this sort of situation is always to rewrite it initially as a power. But note, this cube root in the denominator means it's a negative power, and the cube root means it's fractional. So mathematically speaking, this is x squared plus x plus 1 to the negative 1/3 power. Okay, we would like to find f prime of x. So we are going to, once again, look at our outside function first, and then we'll play around with the inside function. So in this case, our derivative of our outside function is negative 1/3 x squared plus x plus 1, because that's what's inside. And then we're going to drop 1 degree, so negative 1/3 minus 3/3 is negative 4/3, times the derivative of our inside function, which in this case is 2x plus 1. Now to simplify this, let's just be really careful with what we have. So first off, we know it's going to be a fraction. We know that it is negative. We know that the denominator will have a 3 because of the 1/3. We know that the denominator will also have x squared plus x plus 1, but it will be cube rooted. So we have the cube root of x squared plus x plus 1 to the power of 4 because of that 4/3. All of this belongs in the denominator because it's negative. And then this 2x plus 1 is what's left in our numerator. So negative 2x plus 1, just like that. Now do note, it is likely that we would probably distribute that negative. So it might be written as negative 2x minus 1 over 3 times the cube root of, in parentheses, x squared plus x plus 1 to the power of 4. And that's it. So that's our first half of our chain rule lesson. I hope to be back in class tomorrow. I would like you to work these problems right here. This is our 3-6A. Please feel free to message me if you have any questions.